All right, so now we are using the compound interest formula, and it's a little more complicated than the simple interest formula because we have a new variable here. The variable is m, and m represents the oftenness of the compounding, so how often the interest rate is compounded in the year. So if it's annual compounding, m is 1. If it's quarterly compounding, that's 4 times a year, m is 4. Monthly compounding is 12 times a year, so m is 12. And right above problem 7, I wrote some very common oftennesses, which is a word I just made up. So those are some very common numbers that you will see throughout the finance unit. So in problem 7, it is asking us to find the amount owed on a $3,750 loan, and the loan is for 1 year. It is compounded monthly, and it's 7.5% converted to a decimal here for R. The amount of the loan is $3,750, and we're asked for how much we need to pay back. So that's what we do. We know where we start, we just don't know where we end up. And this is the formula we're asked to use. This is the generic compound interest formula. And so since we know everything except A, this is just a substitute and calculator punch problem. So just be careful that you don't substitute incorrectly. And I would do that calculator punch twice, just to make sure you don't do anything silly along the way. But you end up owing $4,041.12. So this was the loan amount, but after interest, you end up paying this amount back. If you needed to find the interest amount, by the way, you would just subtract $3,750 from this, because again, similar to simple interest, it's the amount you pay back is equal to the principal plus the interest. The reason that we can't use the I equals PRT, that type of formula here, is because this is not a simple interest problem. Interest is a little more complicated than that because of the compounding, hence the value, the variable m, and it's a different problem. It's a little different process. All right, going on to problem 8, it says to find the amount invested if the balance is $41,235 on an investment made at 8% compounded weekly, 5 years. Okay, find the amount invested. That's the beginning amount. The balance, the $41,000 amount, that's the ending amount. So make sure you understand the problem before you try to solve it. So we do not know where we start, but we know the balance where we end. It's 8% weekly compounding, 5 years. So here's that formula again. This time, however, we need to solve for P. So you got 2 ways you could do this. You could rearrange this formula right off the bat for P equals and just divide by, well, quite frankly, this mess right here. Or you could just substitute in and then do the solving. I believe I've done it both ways throughout this homework set here, so this practice set. So this one I just substituted in, and you can do whichever way you like. And then, I mean, that's a little bit of a mess, but I need to solve for P. So I need to divide both sides by all of this. I think that's just what I wrote. It is. And then this is going straight in my calculator. So put this in my calculator. I would probably do it twice again just to make sure I don't do anything silly. And we end up with $27,649.14. So going back up here, this is the amount that was... This is the amount that was invested, so that's my starting amount. This is the amount, the balance at the end. So we started with the $27,000 amount, we ended at the $41,000 amount, and this is at 8% interest, compounded weekly for 5 years. So in our problems, P will always be smaller than A. We don't lose money in Math 1630. So P will always be smaller than A. Starting amount will always be smaller than our ending amount, so that might help you just for some clarification as you go through and help you reason through some of your setup processes. All right, we're going to jump over to problem 9. So we're still working with the same formula here. And in problem 9, it says find the amount borrowed if the amount repaid is $9,875.23. We're repaying this. It said find the amount borrowed. We don't know where we start, but we do know what we have to pay back. It's 4.5% interest, compounded quarterly. Time was 24 months. We still have to convert that to years, so we have to use time as 2. Again, you do not have to write the words out. That's just for clarification. So in 2 years, we need to know where we started. We do know where we ended up. And so same formula because it's compound interest. We're looking for P. So this time I've rearranged the formula and solved it for P just to show you a different option. And now I'm going to substitute in. It's going to look a lot like the last problem. It's just I did it in a different order, and it's your choice. And then this is calculator punch. Be smart to do that twice just to make sure you don't do anything silly or accidentally make a mistake. And so we know we ended up at $98.75.23, and it turns out that the amount borrowed was $9,029.82. So here's where we started. Here's where we ended up. That was our interest rate, compounded quarterly for 2 years. All right, and now we're going to jump along to problem 10. Problem 10 is a little different animal. This one is saying how long, asking you to find out how long it's going to take for $5,000 to become $6,000. So here's the given information, and it's a little different. How long will it take? What's the time for $5,000 to become $6,000? Here's where we start. Here's where we end up. It's 4.2% interest, compounded monthly. We don't know how long it's going to take. I do know my answer is going to be in years because time is always in years. So I know that. Here's the formula we were asked to use, and I'm going to substitute in. I have everything except t. So for the first time, we're seeing a problem where we do not know a value of a variable in the exponent. So substituting in, here we go. Now, these numbers aren't too bad. So I'm going to clean this up a little bit and do a little bit of solving here. So I'm going to show you where I end up immediately. Okay, so how did I get there? You can probably figure it out. It doesn't take too much. I divided both sides by 5,000. So 6,000 divided by 5,000 is 1.2. Nice number. That's not rounded. If it had been an ugly number, I would have had to just leave it as a fraction. And then I took a chance to see what happened here. And I went ahead and tried to simplify this, and it simplifies to 1.0035, which is not bad. The 12t is still my exponent. So I got a little bit lucky here. Well, I made the problem, so I kind of forced it to be lucky, but this is not a bad number, and actually that's not too bad, because I want to be able to show you how to solve this, refresh your memory. Some of you may be going, oh yeah, I got this. I remember how to solve when the variable is in the exponent, but some of you may be going, oops, I don't remember this. Here's the process. What you need to do is you need to take the log of both sides of your equation. That's what we need to do. So we need to take the log on the left-hand side. When you take the log of 1.2, it becomes log of 1.2. That's not very creative. When you take, let me cover this up for just a second. Oops. When you take the log of the right-hand side, here's what happens. When we take the log of the right-hand side, what the benefit of this is to take this 12t exponent, and the 12t exponent will come out in front of this in the role of a coefficient. So on the right-hand side, we end up with 12t. I highlighted t because sometimes he can get lost. But 12t times the log of 1.0035. So take a look at this, because it's been a while perhaps since you've solved this way, and I just want to make sure you're okay with it. So you're taking the log of both sides, so you take the log of 1.2, and when you take the log of the entire right side, the end result is that 12t comes out front, and then you're taking the log of 1.0035. The biggest mistake I see is that students treat the log as a variable. It is not. Log is not a variable. You're taking the log of a number. It's something that you're doing to the number. So you cannot put log at the end, for example. You're taking the log of a number, so you've got to be careful with how you write that. And we're solving for t. So if we just divide both sides by everything that's not t, then that's going to give us our solution. So if you divide this side by 12 log of 1.0035, if you divide this side by 12 log of 1.0035, everything cancels except the t, so I just kind of flopped that over here, moved it to the left. This is calculator punch, straight up calculator punch, and you end up with t is about 4.35, and time is in years, so make sure you label that in years. So just look back over this. It's a fairly easy step to do, but again, if you've not done it in a while, you're going to have forgotten that. And if you have any questions about that, let me know. But taking the log of both sides is definitely the quickest way to get you to your answer. And if you have any issues, make sure you reach out.